Harold? Stop. Okay, let's go ahead and get on to this theoretical and experimental probability. So yesterday and the day before, we talked about the basic idea, the likeliness of probability. Points from your house. Talked about the simple idea of probability. So now we're going to talk about two key terminologies. So here's some more words to add to that vocab setting. Theoretical probability. So for theoretical probability, that's what we essentially have been doing already. We have already been working on theoretical probability. That is the number of favorable outcomes over the number of possible outcomes. So we call this type of probability is what should happen. So if I flip a coin, I should land on heads half of the time that I flip it. That's the theoretical probability. Okay, so let's write that down. That probability of flipping a coin and landing on heads should technically be 1/2 or 0.5 or 50% as we know it. Okay, we know that that's what the idea of it is. But then you've got what we call experimental probability. And in experimental probability, there's actions actually happening. You are performing the coin flip. You are actively flipping the coin and recording the results over and over and over again. So what we call this, it's the probability of what actually happens. So yes, in theory, if I flip my coin 2 times, in theory I should land on heads once and tails once. Does that always happen? No. If you flip a coin, it lands on heads, it might land on heads again the second time. It might land on heads again the third time. You might flip it 10 times and it lands on heads 9 of those times. Okay? The thought is experimental probability is your actual recorded results. What is actively happening? It's kind of like studying, right? Yeah. In theory, if you study, you should do well on the test. But by a show of hands, how many of you have studied but didn't perform so well? Okay, it happens sometimes, okay? It doesn't mean that you're not going to perform well the next time, okay? It's just the result of what happens. In theory is different than actual practice, okay? Now, experimental probability, that's the number of times your specific event actually occurred over the total number of trials. Remember we talked about the word trials. Who can remind us, when I say trials, what do I mean? Darius?
How many times you try?
How many times you try, right? How many times you flip the coin? How many times you roll the die? How many times you spin the spinner? Okay? So that's different than theoretical probability. Theoretical probability is based off of the actual item. Experimental probability is based off of you performing an experiment, actively doing something. Okay? So for here, let's say, okay, this is based off of the coin itself, but now let's say that I took that coin and I flipped the coin 30 times. And my results were heads was 8 and tails was 22. Well, then now the probability of heads is no longer 1/2. The probability of heads is now 8 out of 30 because I did an experiment, and these were the results of that experiment. And we know that 8 over 30 would simplify to 4 over 15. That's the same thing of about 0.26 and the 6 repeats. That's approximately 26.6 repeated percent. Okay? So again, there's that difference. Theoretical probability, it's just a theory. It's an idea. Nothing's actually happening. You're just looking at the item. It's the physical item. Experimental probability, an action has to be happening. So if you want to put down that theoretical probability, no action, experimental probability, action, you can do that. That way you guys keep in mind and remember the difference between the two. Okay, so let's take a look at the slide below. So here it says that we've got a graph that's showing the results of an experiment in which we spin a spinner with 3 equal sections, and we performed it for 60 trials, right? We spun it 60 times. So I want to know what's the theoretical probability of red, and then I want to compare that to the experimental probability of red. Okay, so the theoretical probability. For my theoretical probability, again, theoretical, is there an action happening? No. Nothing's happening. All I have to go off of is the item, right? So it says that we have a 3-section spinner. So I'm going to go ahead and draw a 3-section spinner because they don't have it showing here. They've got results shown, but they don't have the actual spinner shown. But I can draw it. I can draw a circle. That's what a spinner looks like. And I can split it up into 3 equal sections. So there's my spinner. And what are the colors of my spinner?
Green, blue, and red.
Green, blue, and red, right? So I'm going to go ahead and I'm going to color one of these sections green. I'm going to color one of the sections blue. And then one of them red. Or pink, because I don't really have a red. Okay? So now, this is what my theoretical probability is based off of. The item, the spinner, or the die, or the coin, or the bag of marbles. It's based off of the item, not the action. So based off of my item, what is the theoretical probability of spinning red? So before I ever spin it, how often should I land on red?
1/3.
1/3, right? So for theoretical probability, I know that there's one section that's red, right? This is the red. There's only one section that's red. And then the total is 3. I have 3 total sections. So 1/3 is my experimental probability. I mean, my theoretical probability. And that's approximately 33.3%. Okay, so 1/3, about 33.3%. Yeah.
Every time when you do an estimate, you do that type of
Yeah, it looks like a equal sign, but it's kind of wavy. That's an approximation sign. Okay? Now, the experimental probability. That means there has to be action. That's where this chart comes into play, because this chart says, hey, it's the spinner's results. Well, results means when you've actually spun the spinner, here's what it landed on. This is the frequency of it. So we've got blue that we landed on. How many times did we land on blue? 15. How many times did we land on green? 21. And how many times did we land on the red? 24. So now, when I want to do the experimental probability, that's based off of not just the red, but the number of times that we landed on red. So how many times was red? 24, right? There were 24 times that we landed on red. And then for my denominator, that's the total trials. So how many total trials? 60, right? It says, hey, you're going to spin the spinner 60 times, right? And even if we didn't see that in there, we could have easily just added all the results together. 21 plus 15 plus 14, that's going to equal 60. So we've got 24 over 60. Now, this can be simplified. You can type it in your calculator if you don't remember how to simplify it, but you can type 24 over 60 and hit enter, and it'll simplify it for you. What do we get when we simplify it? 2/5. Very good. So this really becomes 2/5, which as a percentage, actually it's not even approximate, it's just exactly 40%. Okay, so now for here, I want to compare them. I want to compare those two probabilities. So I want to look and say, okay, well here, my theoretical probability is 33.3%, right? And my experimental probability was 40%. Are they close?
Yes.
No.
Yes, kind of. I mean, they're not too far off, but when we're talking about probability, even though it's only about 6.7% off, that's actually pretty big with probability. Okay, it's a pretty big difference. So, but not too big of a difference to be concerned. So which one's greater?
40%.
The 40%. So 33.3% is less than 40%. But they're almost close. Yes.
Okay, so why did you do like the like that?
The less than sign?
Yeah.
Because 33.3% is less than 40%.
Oh.
Right? I know that the 40% is greater, so remember your symbol, your inequality symbol, it's kind of like the gator mouth. The gator wants to eat the larger quantity. Right? I mean, that's what you guys learned back in, what, 4th grade, 5th grade?
Yeah.
The gator wants the majority of the cookies, or whatever it is. Huh? In 5th grade? Yeah. So that's our less than symbol, stating that the first quantity is less than the second quantity. All right, we're going to finish these notes on Monday when you come in, and then we're going to do a little activity comparing theoreticals and experimentals together.